The problem reads a solid disc pulley of mass 2 kilograms and radius 0.5 meters is used in a system where a 0.5 kilogram mass hangs from a string wrapped around the pulley. The pulley rotates without friction and the string does not slip. We are asked to find the angular acceleration of the pulley and the tension in the string. We are also given a hint that the inertia of a solid disk pulley is equal to 1/2 the mass times the radius squared. If you remember from your equation sheet, we also have this expression that the angular acceleration times the radius is equal to the linear acceleration. One more equation that we're going to need from our equation sheet is that the angular acceleration of a system is equal to the sum of the torques in the system divided by the inertia in the system. To use this, we're going to solve for the torque, multiply both sides by the inertia, given that the torque is equal to the angular acceleration times the inertia. The other equation for torque is the force times the radius times sine of the angle. If we're looking at the forces acting on the disc, we have the tension that's pulling downwards, so the force is the tension of the string times the radius of the disc times, if we look at the angle in which the torque is being applied, it's a 90-degree angle, and we know that sine of 90 degrees is equal to 1. So I'm just going to drop it from our equation. This is the key. We're going to substitute the angular acceleration times the inertia in for this side of the torque. So I'm going to take this and substitute it in for that. We have angular acceleration times the inertia is equal to the tension of the string times the radius of the disc. And then divide both sides by the radius. So we are left with the tension of the string is equal to the angular acceleration times the inertia divided by the radius. And now our next step is to break down the forces in the y direction, the sum of the forces in the y direction. We have, let's call down our positive direction and up our negative direction. So if we're going to do that, our weight is positive minus the tension, and that's all equal to the mass and the linear acceleration. And since we already know that linear acceleration is the angular acceleration times the radius, we can substitute that in. And we know that the tension is angular acceleration times the inertia divided by the radius, so we could substitute that in. So this is telling us that the sum of the forces in the y direction are the weight minus alpha times inertia divided by the radius, and that's all equal to the mass times the angular acceleration times the radius. Remember our goal? Our goal is to find the angular acceleration of the pulley. So we have to solve for angular acceleration, right? So we have our weight is on the left-hand side, and I want to have alpha and alpha here on the same side of the equation. So I'm going to keep our weight on the left-hand side, and what I'm going to do is I'm going to add alpha times the inertia divided by the radius to both sides. So we have our weight equals mass times angular acceleration times the radius plus angular acceleration times inertia divided by the radius. And now what I want to do is divide angular acceleration from both, or factor out. So we have weight is equal to angular acceleration times, what I meant is factor out. So it's now on the outside, mass times radius plus inertia divided by the radius. Now, if I just want to solve for the angular acceleration without plugging in my numbers, I'm going to divide everything by mr plus I over r, mr plus I over r. This becomes 1, leaving me with just alpha on the right-hand side. So alpha is equal to the weight divided by the mass times the radius plus the inertia divided by the radius. And we know that all I'm going to do is switch. I like my alpha on the left. Alpha is equal to the weight, and the weight is mass times gravity divided by mass times the radius plus the inertia divided by the radius. And now all I have to do is plug in my numbers, and my result is 11.76 rads per second squared. I'm going to let you guys plug in the numbers and check your answer.